so let's continue with video number 2. We're going to begin with number 5. Number 5. So we have a piecewise function. Let f of x be the function defined above, where b is a constant. If f is continuous, what is the value of b? The keyword is continuous. So we say that continuous means your left-hand limit equal to the right-hand limit equal to the point value. In this case, the special value is 5. So now, if you look at the function over here, your f of phi is basically on the left-hand limit. So we're going to do left-hand limit equal to the right-hand limit and evaluate at 5. And then we get x squared plus bx equal to 5 times sine pi over 2 times x at the special point 5, because that is the part they're either connected together or not connected together. So now we got 5 squared plus b times 5 equal to 5 times sine pi over 2 times 5. So 25 plus 5b, and now we have sine 5 pi over 2. So we have to figure out this part over here. So let's sketch pi to pi. So this pi over 2, 3 pi over 2. So we're going to extend it. So pi to pi, 3 pi, 4 pi. So we're going to repeat it again. And then over here, 2.5 pi, that means 5 pi over 2. Okay, so that's exactly what we have. So it's at 1. So we got 5 times 1. 2.5 pi, and the y value is 1. So now you get 25 plus 5b. So we just solve for the b. So we found b equal -4. So we finished question number 5. Let's take a look at number 6. Number 6. You still have a piecewise function. The keyword said f of x is differentiable at x equal 2. So we assume it's differentiable and find the value of c and d. So differentiable, it means the left hand derivative equal to right hand derivative equal to the point value. In this case is 2. And then also the left hand derivative equal to the right hand derivative. So these are the two conditions we had to meet in order to make the piecewise function differentiable. So let's take a look at here. Your f of 2 is on the left piece. So therefore what we're going to do is left hand limit equal to right hand limit. So we get cx plus d equal to x squared minus cx at x equal to 2. So now we do substitution. And then we plus 2c both sides. We got an equation for c plus d equal 4. So we still cannot find what c and d equal to. So we have another part we have to do is the left hand derivative equal to right hand derivative. So we have to do slope. If you had to find the slope, you have to go back to here. So you have to find the derivative of each piece. So if you can do it in one step, you do it in one step. I'm going to show the detailed step just to refresh some people's memory. So the derivative, it will be cx. So it will be mx plus b. So c, and then the derivative of a number d will be 0. So you get c on the left side. Y equal to x squared plus cx. So derivative of x squared is 2x, and the derivative of cx will be c. So we got 2x minus c, and we still substitute x equal 2. So c equal to 2 times 2 minus c. And now we just solve. So we figure out c equal 2. Now we go back over here to find d. So you get 4 times 2 plus d equal 4. So now we just find out what d equal to. So we found it. So d equal to -4. So we finished question number 6. Let's go to question number 7. Question number 7. Question number 7 is said that f of x is a piecewise function. This time you get x not equal to x equal 2. So that means the left hand limit and right hand limit all go to the same piece over here. This is a point 2 comma k. So f of x is continuous x equal 2, where is the value of k. So we say that continuous, that means left hand limit equal to right hand limit and equal to the f of 2. So these two are basically equal to each other because x not equal to. So that means the left hand and right hand go to the same location. There's a hole at x equal 2. And this is a point. This point either fill in the hole or outside. So now if you continuous, so we say that they have to be equal in order to you continue to equal 2. So this part will be the left side or the only equation. And then that's k. So we just solve for this equation at x equal 2. We cannot directly substitute it because you got 2 minus 2. So we need to simplify it first. So we got 2x plus 1 equal k, and then 2 times 2, and now we got 5. So k equal 5. Let's take a look at number 8. Number 8. So you have very typical question that may be in the free response question. So we get limit as x tends to infinity e to the negative x. So on the AP exam for free response, love to give us a limit as x tends to infinity with either the exponential function or natural log. So for this kind of situation, the first thing you should do is do substitution because there's no denominator to consider. So you got e to the negative infinity plus 500. So over here, this one become e to the infinity, and the denominator, negative exponent, turn into this. So after this, you get e to the infinity become infinity, and 1 stay the same. 1 divided by huge number, you will see like 0.00 something, so it rounds to 0. So therefore, the answer is 500. So now let's take a look at number 9. Number 9, so we got another one with e to something. So we do the same thing because there's no denominator to consider. So we do substitution. So e to the 2 times infinity plus 500. So e to the 2 to the infinity, so it becomes e to infinity. So when e to the huge number, like e to 1000, it becomes another huge number. So infinity is not a huge number. A huge number plus 500 just become another huge number. So it tells us that this is increasing forever. The limit technically does not exist. Let's take a look at number 10. Number 10. This time we have fraction. We do have denominator to look at. So there are 2 ways to do these questions. So if you look at this one over here, x squared e to the x. So you find out that e to x exponential function, it grows much faster as x tends to infinity. So if your denominator is very huge, and this one increasing very slowly, so definitely you're going to have a number divided by infinity, it will tend to 0. So method number 1, you analyze it. So e to x increases much faster than x squared as x tends to infinity. So you will got a number divided by infinity, and then you will got 0 as long the denominator going to go faster. So you will got a limit equal to 0. So if this method does not work for you, so you can use method number 2. So we're going to have limit as x tend to infinity, x squared e to the x. So we're going to think direct substitution first, because you cannot simplify. So you're going to get infinity squared over e to infinity, which you get infinity over infinity. So once you get infinity over infinity, that will lead you to the L'Hopital's rule. Some people call it the hospital's rule. So now you're going to do is find the derivative of the top, and then you find the derivative of the bottom. Okay, derivative of numerator over derivative of denominator, then sub. So now we're going to find the derivative of the numerator. So we're going to get is 2x. And denominator, the derivative of e to the u times 1. So it'll be e to the x. So now we said then sub. So we sub x equal to infinity. So we get 2 times infinity over e to infinity. We found out we still get the same thing, infinity over infinity. So that means to use the L'Hopital's rule again. You can repeat the L'Hopital's rule as many times as you need. It can be 2 times, 3 times, 4 times, 5 times, 6 times. So here we're going to do it again. So you find the derivative of the numerator, and then we find the derivative of the denominator. So now this one, we're going to get 2. This will be e to x. Now sub again. So we got 2 over e to infinity. Now we don't get this anymore. We got 2 divided by infinity. Then 2 divided by a huge number will approach 0. So we found the answer, 0. So we finished question number 10. Now let's go to number 11. Number 11, you got limit as x tends to 0, sine x over x. So you think direct substitution. So we get sine 0 over 0, which is 0 over 0. So for L'Hopital's rule, there's only 2 conditions. Either 0 over 0 or infinity over infinity. Then you can use the L'Hopital's rule. So now we had this situation. So same idea. You do the derivative of the numerator divided by the derivative of the denominator. So basically due to the top and divided by the due to the bottom. So now we're going to find the derivative of the sine x, which is cosine x. This time I'm going to show less step. The derivative of the x is 1. So x equals 0. So we get cosine 0 over 1. So we don't get 0 anymore. So it worked. Cosine 0. So we already figured out last time. So we get 1 over 1. So the final answer is 1. So we finished question number 11. Now let's go to number 12. Number 12. I am going to use L'Hopital's rule to do number 12. Because if you substitute this, you're going to e to the 2 times infinity will be infinity. If you substitute this, it's also going to give you infinity. So you think e to the 2 times infinity over square root of infinity. You got infinity over infinity. So use L'Hopital's rule. So now we're going to do this. Okay, so limit as x tend to infinity. Okay, e to the 2x and then x to the half. Let's set it up to find the derivative. So we're going to find the derivative at the top. So as I said that, I'm going to skip steps. So you get e to u times u prime. So it'll be e to the 2x times 2. And then you're going to get 1/2 x to the negative half. So I'm going to rewrite the denominator. So you get 2 times e to the 2x. And then you get 1 over 2 square x. So you find out that you can simplify. Then you simplify before you substitute. So now I'm going to go over here and simplify. So I'm going to get limit x tend to infinity. 2 times e to the 2x times the reciprocal. So now I'm going to get 4e to the 2x times square root x. So we don't have to consider denominator 1. So we do substitution. 4 times e to the 2 to infinity. 4 times e to the 2 times infinity times square root infinity. And then you just have a huge number times a huge number times 4 to be another huge number. So we found out that it's a 10 to infinity. So technically the limit doesn't exist. The end behavior tells us it's increasing forever. So we finished question number 12.